Hello everyone, my name is Levi Herman and this is my project on the Venus flower basket. The Venus flower basket, or the Euplectella aspergillum, belongs to the phylum Porifera, or sponges, class Hexactinellida, or glass sponges, which is just sponges with siliceous spicules. Order Lysacinosoda, having unconnected spicules. Family Euplectellidae. Genus Euplectella. And the species under binomial nomenclature, the Euplectella aspergillum. Commercial uses for the Venus flower basket are Euplectella aspergillum. In Japan, the Venus flower basket is often seen as a symbol of eternal love and is generally marketed as a wedding present. This is because in the ocean, each flower basket is known to have a mating pair of shrimp. As you can see here, the shrimp are within the flower basket, and there's a juvenile one right there. Note, the mating pair of shrimp inside the Venus flower basket are generally unable to leave due to their size, so they live in there with symbiosis, mutualism with the sponge until death. As you can see, they're a lot bigger than the holes, so they're kind of stuck. Structure of the Venus flower basket. The Venus flower basket piques in interest by humanity as it's a step ahead of us in the process of its engineering. It can be stated that humans are looking at its characteristics when engineering skyscrapers. Venus flower basket is most efficient structurally for its structure as well as its resource efficiency. Note, the Venus flower basket reinforces every other square. This provides most stability for the structure for this organism with the least metabolic cost. And then here are some similarities between the human buildings and Mother Nature's. As you can see, ours is a cylindrous shape and we're reinforcing everything pretty much. But the Venus flower basket is reinforcing what it needs to, and it has a very similar shape. Optics. So the Venus flower basket is known widely for its fiber optics. It compares to the same fiber optics that humanity uses, but it's better in a lot of ways. There is a little to no sunlight at the Venus flower basket's depth, but there is some bioluminescent bacteria. So the fiber optic skeletons are developed by this organism to absorb and disperse this light to the rest of the skeleton. As you can see here, it's very interesting how it works. Just a note about the fiber optics produced by the Venus flower basket. They are better able to transmit light and are more flexible than its industrial counterpart. Basically better in every single way. Mother Nature trumps humanity in this case. Of these two factors, Mother Nature proved better with its millions of years experience. The sponge evolved a strong structure as a result of the environmental pressures the organism faces on a day-to-day basis, as well as it evolves superior optics because of the lack of light that reaches that depth in the ocean. Are these traits existent in other members of the species? The trait of fiber optics exists only within the class Hexactinellida, or glass sponges. The trait of having advanced structure or reinforcement of every other structure of the sponge's skeleton is at this moment only recognized within this species of sponge, making it just this much more important for us to research. And here are my references which I got my information from.